Here I'm finishing up the notes for 1.6 day 2, and so I just kind of split it up into these two parts. Let's look at both example 6 and then example 7 on the next page. Here, if you take a look at this graph, it's in our absolute value. Remember, this is your horizontal shift. We always move it in the opposite direction, so it's a right shift of 2. So something like this is what it looks like, right? You can see it passes the vertical line test, so it's a function. It fails the horizontal line test, therefore it is not an inverse, and it is not one-to-one. What this is challenging us to do is let's delete part of the graph, kind of like what we did up here on the previous example. We used a domain restriction to only show some of the parabola, and that's really the trick into this problem here as well. We're going to use a domain restriction to remove part of the graph, delete part of the graph, so that part that remains is one-to-one. And then we'll find the inverse of the remaining part and give the domain on the inverse. Okay, so there are two branches. What if we just remove half of the branch? We could either remove the right half or we could remove the left half. Let's do that. So we're going to just use the domain starting at 2 and greater than 2. So we're going to take this function and modify it slightly. We're going to take this absolute value and say this is true only for x greater than or equal to 2, right? So there's my domain restriction. And so what that means for us then is our graph looks like this. In other words, it's just a straight line. So because it's a straight line, let's just rewrite this as the equation of a line. Right, so there's my slope of 1. Notice it's not an absolute value anymore because we don't have an absolute value anymore. It's just a straight line. But the line doesn't go on forever, so we're still needing that domain restriction. Okay, let's find the inverse. So we learned we can swap x with y and solve for y, and then throw out the y and return that to function notation. So f inverse is x plus 2, meaning we can give it the horizontal line test and it passes. However, there's still a domain restriction, even on the inverse. So we have to say that with our inverse, even though the equation is x plus 2, we can't just walk away. We still have this restriction. All right, so that's the trick. If we have a shape like a parabola or the absolute value, we just look at some of the domain. We don't use all of it. All right, let's finish up with example 7. Now, there's a lot going on here in example 7 because we are running the composition with the inverses or finding the inverse of the composition depending on the notation. So take a look at what we have. We have our two functions. We have f of x and g of x. And notice what's in the parentheses versus what's outside of the parentheses here. So you want to almost think of this like order of operations. You do what's in the parentheses first. So I have to run the composition of two inverses. Well, they didn't give me inverses, so we actually have to find the inverses first, and then we take one inverse and plug into it the second inverse. As opposed to this problem here, this is f composed with g. Those are the normal functions. So we do that first because that'll be inside the grouping symbols, if you will, and then we'll find the inverse of that result. So notice what's happening inside the parentheses in each of these so we know what to do first. So let's start off with part A. Once we take care of finding the inverses and running the composition, then as a last step, I'll plug in the -2 to evaluate the function. Okay? So let's start off by first finding the inverse of g. So this is g inverse. So this is the g inverse, which is x cubed. So I'm just replacing that right now with the y. So y equals x cubed. Switch x with y around. Solve for y. So take the cubed root of both sides. And replace that with the inverse notation. G inverse is cubed root of x. Remember, with the cubed root, you don't have a plus or minus. So sometimes students will put a plus or minus on there. That's only with an even root, like a square root or a fourth root. So that's one piece of information that we need. Next, let's find f inverse. So there's the equation. I'll do the substitution, taking the function notation out, putting y in its place. Y equals 1/8 x minus 3. Exchange x with y. And let's work to solve for y. Adding 3 to both sides gives me x plus 3 equals 1/8 y. And now multiply both sides by 8. So you have 8 times the whole left-hand side. So notice I'm wrapping that in parentheses. And we can distribute that 8 as well. So we have f inverse is 8x plus 24. So those are the two key pieces of information that we need. So now we're going to take what's listed first, the G inverse, and plug into it what's listed second, the F inverse. So now we're going to do the composition. So I will find G inverse composed with F inverse. And then we'll plug in that value of -2 as a follow-up step. Okay, so G inverse, that's this one. That's the cubed root of x. And in place of x, we're going to plug in the f inverse. The f inverse is the 8x plus 24. So that's where the substitution is occurring. That 8x plus 24 is going right here in place of that input symbol, in place of that x. So, can you take the cubed root of 8? No, you cannot do that because this is a grouping symbol. We have a binomial here. We have two separate terms. You cannot take the cubed root of some and not the others. Only if it was multiplying values could you take the cubed root of 8, but we're not multiplying, we're adding. So you cannot touch it. That's it. That's the composition. So now we're going to take that result and plug into it the value of -2. So now we're going to find this whole thing evaluated with an input of -2. So again, this is not saying multiplication. We're just saying this is the input. So you take that -2 and you plug it in right there. So it's the cubed root of 8 times the -2 plus 24. And that's what we're going to evaluate. Let's see, what does that give us? 24 and take away 16. I think that gives us exactly 8, and that is a perfect cube. That's interesting. That is a positive 8. So now that is a perfect cube, and that will simplify into a 2, exactly 2. So there's the whole process. You can see that's quite a lot of steps to get to that final result. The trick here is to break it down one piece at a time. First, we found the inverse of the function called g of x. Then we found the inverse of the function called f of x. So we took those results and we composed them. We plugged one into the other. And then we did the evaluation. So lastly, here's part B. Again, do what's on the inside of the parentheses first. Start off with the function called f and plug into it the function called g. All right, so the function called f is the 1/8 x minus 3. We're going to plug into that right here. This is where the input goes. We're going to plug into that the function called g of x. We'll plug in the x cubed. So this is my f composed with g. This is where the substitution is occurring, and we're dropping in the x cubed. If you wanted, you could simplify it like this, write it as an x cubed over 8 with a -3. That's fine. Now take that result and find the inverse. So what we want to do is remove all of that function notation, replace it with a y, and exchange x with y. And now let's solve for y. So add 3 to both sides. And then multiply both sides by 8. And take the cubed root. And replace that with the function notation, which is this thing. That's the problem we were trying to find at the very beginning. So this is the composition inverse. And there it is. Now we can actually simplify it a little bit farther. You realize that this is quite similar to what we saw earlier. It happens to look the same as this. They don't always turn out the same. That's a bit of a coincidence here, but we actually can take the cubed root of this. The trick here is, again, you can't just take the cubed root of the 8 because of the addition sign. You can only take the cubed root of factors. So if we were to simplify it, notice that what we could do is we could factor out an 8. That leaves us with x plus 3. And now that you're multiplying, we could take the cubed root of 8, and that'll give us a normal 2 on the outside, but we still have the cubed root of x plus 3 on the inside. So there's our simplified and reduced form. So there's the final answer for part B.